Welcome to EDU World Space.
In problem 48, we're told to refer to figures 34.43a and b for the case of a zoom lens. And we're given the focal length of the converging lens is 12 centimeters and the focal length of the diverging lens is negative 12 centimeters. And they're separated by a distance d of 4 centimeters. And in part A, we're asked to find the object of the converging lens, which will serve as the image for the diverging lens. So we'll use, and we're also told that the actual object S1 is a distant object, so that means S1 is out at infinity, so it's very far away. And then we can use equation 34.16 to solve for the image of the first lens, which tells us that 1 over S1 plus 1 over S1 primed is 1 over F1. So then we have 1 over infinity for S1 because our object is very far away, and then 1 over S1 primed is equal to 1 over 12 centimeters, or S1 prime is equal to 12 centimeters. So this is 12 centimeters is the image for the converging lens. So let's say we have somewhere here. So this is S1 primed, the image. And now in part B, we have to determine the image of the diverging lens. So notice right away that my image, so now if this is S1 prime and this is D, and then this serves as the object for the second lens, then the object is S2, and we see that S1 primed is D plus S2, right? Because the object is always measured relative to the thin lens, right? So the object for the second lens will be over here at S2 relative to this diverging lens. But notice that the light is coming from the left side, whereas the object for this diverging lens is on the right side. So that tells us that we have a virtual object. Therefore, S2 had better be negative. And so we can solve this for S2. So S2 is equal to D minus S1. And this will give us a negative S1 prime, negative S2. So we have S2 is equal to 4 centimeters, which is the value of D that we're given here, minus 12 centimeters, which is what we found in part A. So that's negative 8 centimeters. So now that we have S2, again, we use equation 16 so to find the image for this diverging lens. So 1 over S2 plus 1 over S2 primed is equal to 1 over F2. And we can just solve this for S2 primed, which is equal to S2 f2 divided by s2 minus f2. And let's just plug in the numbers that we're given. So that's equal to minus 8 centimeters multiplied by minus 12 centimeters divided by minus 8 centimeters minus 12 centimeters. And that is 96 centimeters squared divided by 4 centimeters, which is 24 centimeters. So this image S2, it's positive, so it's 24 centimeters to the right of the lens, and that is the final image. So part C, let's do that next page. So in part C, they're asking where the image is, so it's 24 centimeters to the right. Okay, and in part D, we have to repeat everything again, except that the distance now is 8 centimeters. So to find the object of the first lens, the converging lens, again, we use equation 16. We know that S1 is out at infinity. So 1 over infinity is 0, and that tells us that S1 prime is equal to F1, which is 12 centimeters, same as before. Now, we have, so remember, our picture looked something like this. So this is D, and over here, actually, let me try it at the bottom. So over here we have S1 primed, and over here, this is S2. And as before, S2 is equal to D minus S1 prime. And it's virtual, so that's 8 centimeters minus 12 centimeters. And that's equal to minus 4 centimeters. And now we solve for the image of the diverging lens using the same equation before. So S2 prime is equal to S2 F2 divided by S2 minus F2. So we get minus 4 centimeters minus 12 centimeters divided by minus 4 minus 12 centimeters. And that's 48 centimeters squared divided by 8 centimeters. And that gives us 6 centimeters to the right. And you'll see that the answers that we've gotten here for the final image corresponds to the figures that were referenced in the beginning of the problem.